first is always home the Z-axis, which is the up and down axis. And the reason why you want to do that is because I have stuff down here. So if I start moving my X and Y and my spindle's in the way, I'm going to get a crash. And as an example, on this insert right here, runs about $45. So I don't want to crash into that, break the insert, or worse, break the holder, because then I'm out, $300 or $400. So I'm going to reference the Z first. I'm going to let it run, make sure everything's clear.
How much did it cost?
I'm into this machine total probably about $50,000.
50,000?
Yes.
Tarmac 770?
Yeah, you can buy the base machine for significantly less than that, but measurement tools, this vise just by itself is about $2,000.
Wow.
It's very, it's an expensive hobby.
Doesn't the chips get into the thread here?
Yeah, sure they do. It doesn't hurt anything.
Oh wow.
So
because it's just a vise, it doesn't.
Yeah.
Okay.
The vise doesn't move, the bed moves. So now we're homed. The machine knows that this is basically its 0 point in all axes, and now we can actually start putting material up into it and then measuring it and telling it, kind of where to cut. So that is. Does anybody else have any questions about the machine before we move back to the classroom?
Yeah. What's the coolant? How much does the coolant cost? How much?
So this is a water mix with a coolant that is called Extreme Cut from Qualichem. This is kind of the ubiquitous, high performance coolant that you would see used everywhere. So Qualichem's about $80 a gallon. $80 a gallon, but that'll dilute 20 to 1. So it's not that bad. Also, this is a very low quantity cooling system. I can actually turn it up for you. You can see it's not going to use a ton of coolant. Again, it's just to clear chips and to keep the cutter cool. So of course you can turn it up and really make it spray, but that is not necessary.
Is it toxic?
No. Don't eat it, but it's not gonna hurt you. Any other questions?
How did you fund the purchase of this machine?
I don't have friends or drink or do whatever. I play video games and I build stuff, so
Okay.
I don't have a lot of weird expenses.
Is this
So you will often see them in a job shop, which is a machine shop that specifically concentrates on doing one-off pieces. And this would be used kind of in a tool room to make a fixture, and we'll talk about fixturing in a little bit, or make a one-off part for a specific other process. You could do it with this, certainly, but if you need to make a very high volume product, you would probably go to a very large, very expensive, very rigid machine.
So would this be kind of like the evolution of 3D printing?
This existed certainly before commercial 3D printing existed.
Yeah. But from a proof of concept perspective?
Certainly, yeah. So 3D printing is super useful for a wide range of things. It's not useful for precise parts. It's not useful for particularly strong parts. And of course 3D printing is capable of making strong parts, but not as strong as
with these materials, with these raw materials.
Right.
The other trick you can have with 3D printing is 3D printing works, but not for everything.
Yep.
Particularly for certain things that have overhangs and for
Right.
voids. If you're trying to cut into a void, that's fairly easy.
Right.
But to cast in the 3D printed certain items that have certain voids or certain designs turns out like you have between printing with additive versus subtractive coloring. This is subtractive manufacturing in a sense.
The opposite.
And most 3D printers are an additive manufacturing, and the two are not equivalent
Right.
for everything. There's certain things where additive manufacturing is not practical, but a subtractive manufacturing is much more practical, and that's one of the differences between, I would say, a CNC cutter versus a 3D printer, is whether or not you work for subtractive versus additive.
Right, of course. So 3D printing, like you said, has some strengths. You have a 3D printed part out of a machine that you made.
Yeah.
I
can show there.
Yeah, absolutely. And that part would be virtually impossible to make on this machine in a reasonable amount of time. I could add a fourth axis, which would basically be a twisting motion controller here, and make it relatively easily. But as it sits, 3D printing would be the way to go to make a part like that.
Actually, about strength, it's very questionable. Maybe you can print something really strong.
Right.
I can show you.
Yeah, we'll see.
Does
So
it have the tool change? Can it change?
I am actually waiting on my tool changer right now, but right now, essentially, I'm using a power draw bar.
Oh,
which
so
is
you have
relatively
to,
quick.
like, it pauses and you have to come and
Yeah,
change.
I do a manual tool change, but unfortunately they've been out of stock forever on the automatic tool
How
changers.
much
So
does it cost? That much cost?
the tool changers $4,500 somewhere around there.
Okay.
Yeah.
Now you said you did aluminum. Is there a limitation to this for your material?
I have milled a small amount of Inconel 718, which is about the most intense stuff you can get. So,
Yeah.
it'll
not
do anything.
really?
Not really, no. And really, I mean, truthfully, when it comes to metal cutting, you can just about cut anything with anything, as long as the speed is right and the cutter's right and everything else is right. So,
Do you reuse the coolant?
do I use the coolant?
Reuse.
No. It evaporates, settles on the machine, keeps everything rust free, and then I add more to it. Of course.
You vacuum the chips?
Yep.
How do you vacuum cleaner?
Yep. There's a pile of them in that 5-gallon bucket over there.
Does it work for softer materials or is it overkill?
Nothing's overkill if you need the precision. Certainly the plastics, the precision. This is down to 1/10,000th of an inch.
How much is it in microns? 25 microns? 24.5 microns?
let me find out for you. I think in imperial. I'm sorry.
1,000.
Yeah, 25 microns.
Yeah,
1
that's-
millimeter is 40,000.
Yes, 25 microns.
25 microns.
That's nice. That's very nice.
How much does this weigh? And what was the process of moving this?
Right. Those are very good. He's laughing because it was very. He helped me. He helped me with the dangerous parts. So I think altogether this is probably about 2,000 pounds.
Okay.
So not terribly heavy. Not the 8 to 10 that you would see on like a Haas VF2, or some other smaller bed mill. The process. So unfortunately, the Tormach, the company, shipped the 600-pound base about 5 feet in the air on top of the crate that was holding this, and I did get it down by myself. So, which was fun. I actually there were a few casualties, minor ones, yeah, the rest of it was essentially we used all of these jacks that you see over here and an engine hoist and some wood blocks and some ingenuity, and got it up on the stand. Was not necessarily the safest way to do it. In fact, it was actually quite dangerous. I would recommend, if you were to do this yourself, to get the proper equipment to do it, just because it costs a lot of money and also injury. Right?
Isn't it what?
This is polycarbonate.
Polycarbonate.
Yes.
Awesome.
Yeah, that's very, very dangerous process. Of course, actually, the only way to actually hold this thing in the air is actually to use a T-slot clamp here and one in the back. So as you can imagine, the center of gravity was a little precarious. So he was holding it while I was doing the more dangerous things, and we got it up. Any other questions? Okay, all right. So let's move back to the classroom here. Years ago, it was actually a small cabin.
What's with the condensate tank in the back? Is that yours?
Say what?
There's a condensate tank in the back here. Is that yours?
Yes.
How do you set temperatures too? Are you going to show all this?
Yeah, we'll get to that.
Is there a compressor?
Yeah, air compressor.
What's the compressor for? For the coolant?
Yeah.
Oh, wow.
For your aux functions, like the drawbar, the lube, is there a PLC controlling that, or is it all just like a Windows app?
It's all in the G code. So,
Okay.
And I mean, of course, you can control it manually, right? But I'm telling it in the G code to activate coolant.
Okay, so I deal with a lot of CNCs that have integrated PLCs as well, so we write our own ladder logic for that kind of stuff. I was wondering if you had the ability to add more functions like that, or if it's all just whatever
Yeah,
they
of course.
provided.
Yeah.
Okay.
Actually, let's measure this manually. Thank you, sir. All right. So I have a granite surface plate here. I'm going to go over to this desk. All right. Let's see what happens. So,
Why does it sound pneumatic? Is it clamps it in there?
where?
When you push that,
That is pneumatic.
it sounds pneumatic. So
Yeah.
it's open some jaws and then it goes into the
More or less. I can show you how it works with the setup. And now it's going to go into the interpolating the rest of the hole. You'll see the movement will speed up. There you go. I'm going to turn the coolant up a bit. If you're curious, the tips that come off are really hot.
You recycle all the chips.
Yeah.
How do you do that? Just take a bag of aluminum chips to the
Take them to a So you hear it's a nice, quiet cut. That means that we're not rubbing. We're not, there's nothing kind of bad going on. The pocket's getting a little deep. I'm going to make sure that our chips are getting out.
Better pick that up.
I think this is probably the last stop until it gets through the bottom of the material. I think it probably just broke through just now. I think I can hear it.
surprisingly quiet.
Yeah.
So
Nice.
what did you say it was? 16,000 RPM right now?
This is 10,000.
10,000.
Cool.
Seems kind of odd how it was choosing the the G3s for like the really fine moves and just G1s for all the others
Right.
out there.
Yeah, that's if you use Fusion 360, that tends to be the. So notice how I said earlier that the 2D adaptive strategy is not a good finishing strategy. If you look in there, there are quite a few steps on the diameter here. It looks like very faceted. When we do our 2D contour, those will go away. Okay, so next up, I'm gonna hit cycle start, tool 31, which is our drill.
Does it look like there's suction in that? Is there suction in that?
Suction?
Yeah.
There's no suction.
No.
To hold the tools in.
Yeah.
Yeah, so actually let's talk about the drawbar real quick. So up here is a power drawbar. This is basically a pneumatic piston. When I hit the button, this goes down a little bit, pushes down on these disc springs and releases the collet on the tool.
And does it auto self-align so it knows exactly where zero's at? Because
Yeah.
you put in how long it was.
Right, so
Because that's got to be pretty precise.
So it's telling me
Right.
tool 31, which I actually already measured with a thing that's repeatable down to a millionth of an inch. Once I basically told it I'd put in tool 31. When I hit cycle start, this will change to tool 31 since I already measured it. It knows what the offset is, and it will do the work. Hopefully. All right, here it goes. Oh, sorry. Yeah. So here's our deep drilling with the. So it's a nice and quiet drill. That's good. I'm And this is just the pre-drill for those 3/8 inch holes.
Did it move it after it was down? So the drill bit has cutting flutes on the side as well as the
No, it shouldn't have moved it when it was already done. If it did, that's disturbing, but it didn't break, and I don't see evidence of that happening, so I don't think that happened.
So I guess a drill bit deals with the pieces better than the other, because of the grooves, it deals with the bits better than the other tool.
You're saying like clearing the chips out? Yeah. Yeah, drill bits, the nature of the flute, they are extracting, they're like augers, basically. Yeah, it goes.
Can you take that other drill bit out? I just wanted to see if it fouled up the aluminum.
Certainly, go for it.
Oh yeah, it's clean. There's nothing.
Let's actually turn our coolant on. Let's make sure that we're getting this in the high. Tight.
So should this be kind of like the final bit that you use?
Yes.
So that's a glycerin air mixture?
Nice and quiet. So these, obviously these chips are big, right? And dangerous as a
Holy
result.
crap.
So you don't want to be messing with them.
That's why there's plexiglass doors.
Right. Cool. So very sharp, but if you, at your own risk, if you'd like to handle a drill bit chip. Oh yeah, I'll get you one.
Or you can have this one. Yeah.
All
Anyone
right.
else? Or?
So that was good. That was a nice, quiet drilling operation. I'm happy with that.
That's cool.
I don't know if I'd handle
Again,
it beyond
if you'd like
this.
to see that one.
Yeah.
That one actually had a tiny bit of a weld there, if you can see.
Oh yeah.
So it's probably a little bit too aggressive of a cut, but it worked.
I've worked with
Throw
high
this
school
back
kids
in?
machining stuff, and they constantly end up getting the drill bits just like
Right.
silvered with aluminum on there because they're either going too slow or
Right,
they don't know what they're doing.
coolant's important. With drilling, you just have to make sure and get the lube on the face, the cutting face with drills,
Right.
because I don't know, that's what retracts are good for. So, all right, so what is our next tool that we need? Tool 22. That is our shear hog. Let me make sure we're cool. This tool has a really lot of material. I'm going to double check that we don't crash. Give me a second.